Okay, so these are the word problems with the triangles that we just spent almost 2 periods doing. A period. Anyway. Period of work time, anyway. So, we're going to take like word problems or words, and we're just going to draw our triangle and solve these things and make an interpretation relative to the triangle. Okay, so one day, so often trig problems involve sightings by an observer. Okay, these sightings or angles are recorded and calculations are made. Okay, so there's some new terminology here for you quickly. There's what we call like the angle of depression and the angle of elevation. So elevation means up. All right, so the angle of elevation is measured upwards from the horizontal, and the angle of depression is measured down. Okay? Those are just 2 new words for you. So when if we throw that in the word problem, you're able to look at that and go, okay, that means I'm going to measure up or I'm going to measure down. Okay? So with these, you're just going to read the problem carefully, and then step 2 is to just draw the picture as accurately as you can. And then you can write a let statement that says you're going to identify the variable being used, and then then it's from here down is just the stuff we've just spent working on. Identify the ratio you're going to use, solve, and then write a concluding statement based on the question. Okay, so this one here is not too bad. There's nothing too crazy in here. But we have a hydro pole, and it's supported by a guy wire that is 13.7 meters in length. If the wire makes an angle of 73 degrees with the ground, how tall is the pole? Okay, so I'm just going to draw a picture based on what I see here, and then I'm going to solve. Is that a question, Tobias?
Or can we assume that the pole and the ground are either 90 degrees?
Yeah, that's the idea. Yeah. Right, so these questions are geared around the assumption that they're right angle triangles. Is what these are geared around. We're going to do triangles that are not 90-degree triangles maybe this afternoon, depending on how you guys decide to work. Right? Might be Monday, I don't know. That's the last 2 lessons of the unit. Okay? So, I'm going to drive the telephone pole or whatever this hydro pole. Right? And it meets the ground at 90 degrees. Right? And it's supported by a wire 13.7 meters in length. Right? And then it tells us the angle that the wire meets the ground at is 73 degrees. Okay? That's your picture. That looks like a question from this morning already. So I'm standing at the 73. Remember this is the thing that we're looking for, the height of the telephone pole, right? I'm going to label it H. I'm standing here at the angle. What is H relative to the angle? It's opposite. And I know the hypotenuse is 13.7. Once you know those 2 things, you can select a primary trig ratio to use. And away you go. That's just a question from this morning. So I see opposite and hypotenuse. That looks like O and H. So I'm going to select sine. The sine of theta should be equal to O over H. Then I'm just going to make this appropriate substitutions for my picture. O is the thing I want, which represents the height of the pole. I know in our let statements here we said, up here, we said let's write a let statement. So let's say let H represent the height of the pole or something. Okay, then that actually has meaning when I solve for h. That's all the let statement's doing for you. Okay, so sine theta, sine 37 is equal to O over 13.7. Well, it's 73, sorry. It's the angle, right? Now my job here, I guess I should have made the substitution for opposite. Opposite was h, little h. Not hypotenuse, little h. It's the height of the pole. Sorry, I should have chose a different letter instead of h. H looks like hypotenuse, but it's not. It's little h, not big H. Okay? You do whatever you want. Okay, so I'm solving for the height. So how do I get the height by itself? Multiply both sides by 13.7. So the height (13.7) multiplied by the sine of 73. Okay, and then you're going to go back to the table, right? You're going to go find 73 underneath sine, which is right here. You're going to read across and read the decimal off of from underneath sine. 0.9563. Okay, what's that number? 13.7 times 0.9563 is 13.1 meters. And you can say, therefore, the height is 13.1 meters. It's okay? Maybe on Monday I'll bring something on Monday and we'll do a little experiment outside or something. I'll explain it after. Okay, we'll do something on Monday maybe. As a class, we'll go outside or something. If it's nice out. I'll explain it after. Okay, here we go. A construction engineer determines that a road must rise vertically 35 meters over a 200-meter horizontal distance of roadway. Calculate the angle of elevation of the road. In Ontario, the maximum angle of elevation is 12 degrees. Does the road need to be redesigned is the question. Okay, so we'll just draw our picture, right? It says the road needs to have or increase its height vertically, right, by 35 meters. It needs to do that over the course of 200 meters. Your job is to figure out the angle in there. Theta. Okay. So, I'm standing at theta, right? And I'm like, okay, well, 35 must be opposite. This is still a 90 degree down in here, so this must be hypotenuse, which must make this adjacent. So I have two pieces of information that I know. One of them is opposite. One of them is adjacent. Right? What am I going to do? I'm going to write SOHCAHTOA up here. And then I'm going to make a selection from SOHCAHTOA based on the information that I know. I know opposite and I know adjacent. Opposite, adjacent. I'm going to select tangent. Right? Tan theta is equal to opposite over adjacent, which is going to equal 35 over 200. This is what's kind of cool about this table, is you're going to go find this decimal on the table or something pretty close to it. They're completely two random numbers. I could have made this question like 45 and 300. Still would have found a decimal on the table. That's what I find cool about it. So we just need a decimal for 35 divided by 200. What's that? If you're looking at your table right now, you would have already found the number I'm looking for, and you can yell it out at any time. So we go to our table. I'm not going to go back. You guys can go to the table. We're going to go underneath the tangent column because that's what we're using. And you'll find that decimal value, 0.175. What's that, sorry?
The theta is 1. So 0.175 in the table goes to the 1.
I see. Okay, I'll go to the table for this one.
No, because that's 0.0175.
Yeah, be careful. That's
So it actually goes to 10, right?
yeah, it's somewhere between. If you take a look at these two numbers here, between 10 and 11. Let's look at the decimal values between 10 and 11. Our number is somewhere. What's our number again?
Well, 0.175.
Okay, so it's a little bit on this side of this decimal number, right?
Wait, isn't that not assigned enough? Like, are we
Nope. We're under tangent, right? Using tangent, so underneath the tangent column. And our number is on the arrow side of that decimal number. So that must mean that my angle is like 9.9 or 9.8 or something. But you're okay saying 10. I'm okay with that. You find the closest decimal value. I'm just trying to illustrate to you that you can interpret here a little bit. Okay, it's pretty close to 10. So something probably 9.8 is good, right? 10, it's fine. So if I go back here now, I know theta. Theta has to equal 10 degrees. So let's relate it back to our thing here. The maximum angle of elevation is 12 degrees. Does this road meet the requirements under these conditions? Yes, right? Because 10 degrees is less than 12. If it's more than 12, what's going to happen? Like, say in the winter, are you ever going to get your car up it? No. That's probably why it's a maximum, right? And it probably changes from area to area based on weather. Right? So yes, the road, we'll say the road is to code. Has anybody been by John Counter and the train station that's down there? John Counter? Somebody had to figure out how far back they had to start that bridge. Was it 200 meters? Was it 500 meters? Somebody had to figure out how far back to start that bridge so that the angle was appropriate at the bottom. They obviously knew how tall the bridge had to go so that the trains didn't slam into it. So the only thing that they could change was how far back they had to start the road in order to get it to that area, like by abiding by the angle. Does that make sense? Here's a real world example. In your backyard. Same thing's gonna have to happen when they do the third crossing. They're probably gonna be thinking about the boats that go through there. Although they might not have boats going underneath the bridge, I don't know. I have a hard time spatially visualizing where that third crossing goes, I don't know. The one, they built a new bridge on John Counter.
On Montreal Street.
By Montreal Street there. And it goes up over the train tracks.
I know.
That's what I'm saying. But there's another one. Oh, the third crossing is the one by Montreal Street. Okay, that was a big one. That's like a $90 million project or something like that?
I think so.
30 came from the city, 30 came from the province, 30 came from the federal government, I think, to pay for that bridge. So $90 million project, that one. So you can imagine the kind of math that was going on with that thing. Make sure they get that right. Right? Is that good? What's next? Let's do another one. Got two office buildings here.
Wait, do we have a quiz there?
Yes.
Unit 4, right?
It's just completing the square. I feel like I've answered that question 10 times today. And I think I said it 10 times yesterday too.
You said you're gonna go over a couple of the word problems?
Yeah, we'll do that in last
Before
period.
or
After.
Why after?
It's not on it.
Oh, word problems are not it.
Word problems are not on it.
Oh.
Word problems will be a quiz on Monday. They'll be on your test on Tuesday. But the word problems will be on, we'll have a quiz on word problems Monday alone. So we'll do a couple in last period today. Make sure everybody's all good. And then we'll do a quiz on Monday. Okay? I don't know whether or not I have enough time to do this question. Here, let's leave this one till after. I don't know if I have enough time right now. We'll do this one later. Okay, we'll do let's do this question though. This one's an easy one. Okay. So the foot of a ladder is 4 meters from a wall. Here's your wall. The foot of the ladder is going to be 4 meters from it. 4 meters. Here's your ladder. The ladder makes an angle of 70 degrees with the ground. What is the length of the ladder? Let's call it X. Okay. Again, obviously the wall meets the ground at 90 degrees, hopefully. Otherwise your house is in a little bit of a trouble. Okay. Means it's fallen over. Okay. I need to solve for X. I'm standing here at 70. Here's opposite. Here's adjacent. Here's hypotenuse. What do I know? What do I want to find out? I want to find X. X in this question is what? Hypotenuse. So let's write our SOHCAHTOA and make a decision. I know the selection I make has to involve hypotenuse because that's the thing I'm looking for. Tangent does not involve hypotenuse. Right? So I'm not going to pick that tangent. There's no H in there. Next choice. I know adjacent and I don't know hypotenuse, or I don't know opposite. So if I don't know opposite, then I'm not picking sine. Right? I know adjacent and I know an angle. I want hypotenuse. So I'm going to select cosine. So the cosine of theta is equal to X over, adjacent A over hypotenuse. I'm going to plug in the angle of 70 degrees into theta. So cosine of 70 is equal to A is 4, H is X. Solve for x. How are you going to do that? Good question. You're going to see this all over the place. You're going to need to know how to do this. There's a problem with this one. How are you going to get x by itself? Lucas. Okay, if you multiply by 4, then you're going to get, that's the typical response. Is we're gonna multiply by 4, and under normal circumstances that would be the case. But what did the 4 cancel here? No. Right, because now you're going to get 16 on the right side. It's the right idea. We just got to do some trickery here. Yes, Retta. Yes. I have to reverse kind of what's gone on here. These are a little bit harder, but not really, because it's just one more step. You're going to multiply by x. Well, that looks like 2 x's on both sides. Now the x's are going to cancel. And then from there, you're allowed to divide both sides by cosine 70. Because then they drop out. So now x is equal to 4 divided by the cosine of 70. Cosine of 70 should be, if you guys look at your table, you're going to go find 70 degrees in the left-hand column and read over to 0.3420. So x is equal to 4 divided by 0.3420. Is that what I said? Yep. So x is equal to 13, is it?
No, that's not even exactly.
Oh, okay, okay.
Yeah, it's like 12.8 or
Oh, yeah.
Couldn't you also just cross multiply?
You can also cross multiply. Good.
something. What's the answer?
I don't know, I have to type it in. Oh, that's worth noting. I'll do that again in a second here.
11.6.
Well, don't tell me after I've already started. You're going to mess me up. It's 11.7 meters, right? Okay, there's your answer. So, okay, here's what Ella said. This is good for some of you that you won't make the mistake that is typical with this. Cos 70 is equal to 4 over x. What is cos 70 over, imaginary wise? Over 1? You can cross multiply here. You get 4 is equal to x cos 70. Divide both sides by cos 70. Okay, I'll stop there. We'll do some more later. Well, last period will be like a little bit of this, some work time, and then we'll do some word problems with the Unit 4 stuff. Okay, that'll be last period today. Okay. Just before we go for lunch or whatever, we'll talk about. I can't see the cursor. What is going on here?